our warm-up today. How would you graph this without a calculator? Can you draw a sketch in the upper right-hand corner of your notes? Graph by hand. Do you know the basic shape? Do you know if it shifts up, down, left, or right? Is it right side up, upside down? And what does the 2 in front do? What does it do to the graph itself? All right, if you're up to date, first question, what is the general shape? Parabola. It's a U, right? What does the +4 do at the end?
It moves it up 4.
Moves it up 4. That was not meant for the stage. +4 is going to move the vertex up 4. What does the minus out front do?
Flips it.
Flips it. So 1, 2, 3, 4. Key vertex point is here. It's going to open downward. What did the 2 do to the graph? Did it make it thinner or wider?
Thinner.
Thinner. So instead of going over 1, down 1, I'm going to go over 1, down 2 with my graph. Key points. Okay? So the rules that you've internalized are still going to apply to the new graphs. They're just going to affect the graphs a little bit differently because we're dealing with continuous waves. So yesterday, you did a bonus lab activity. It was actually a lab where you calculated the decimals that match to the sine values and the cosine values, and you plotted them. If you did this correctly, you would have gotten smooth curves that look like this. If you have things that are back and forth all over the place, you either made sign mistakes, you put in your calculator wrong, one of the two. Right? Sine and cosine are going to be basic waves. What we're going to do is we're going to look at them from the values of 0 to 2 pi. All right, so you have this in your notes, correct? If you take a look, your first page of notes. I'm going to give you your key points. I'm going to give you your key x and y values. Moving forward, you will need to memorize these. Okay. So if I start out with sine, I'm going to have 3 key points on the center axis. So for right now, I don't want to say on the x-axis. I'm going to call it the center wave axis. I've got them at 0, pi, and 2 pi. At pi over 2, I have a sine of 1, and at 3 pi over 2, I have a sine of -1. Plotting those 5 points, I then connect them to make a smooth curve. That is the new graph, basic graph of sine that I want you to memorize moving forward. 5 key values on the x-axis, -1 to +1. Plot your 5 points. Next question, do you understand that the graph doesn't actually begin and stop at 0 and 2 pi, that it goes on forever with the pattern? Comes down, then we do another revolution, and another revolution, and another revolution. We can go in the negatives and go backwards. Yes? The sine wave, technically, the domain is -infinity to infinity.
Yep.
But we are only going to focus on what we call one period or one complete part of the sine wave, which then we could take and we could repeat, and we could repeat, and we would recreate the entire sine wave. Now, moving on to cosine. Cosine is going to have the same 5 key points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. It also has the same y values from -1 to 1. However, cosine only has 2 points on the center line. So here's my center line, center of my wave. I've only got 2 points. They are at pi over 2 and 3 pi over 2. Up 1, down 1, up 1. Now, way back when, before I escalated the ranks. I used to teach CP. And I had a student that raised his hand, I'll never forget, and he said to me, you know, Mrs. Gomer, I really think the cosine graph looks like a uterus. And I was like, okay, that sounds good. And I tell you that story because, number one, it's weird, and hopefully you'll remember it the way that I remember it so fondly. But I like to look at the cosine graph kind of like the letter C, whereas this kind of looks like an S. Ah.
Yeah.
You see a uterus, then that's cosine.
You do you.
That's right. But you need to know the difference because when you see complete waves, they look exactly alike. They're not in the same place on the x-axis, but they're the same wave. They actually, you can put them on top of each other and everything about them is the same. So let's talk about answering the questions here at the bottom just to give us a context. In the sine graph, what's my maximum value? Why is this going to sleep? Oh. Almost trouble-free. What's my maximum value of the sine graph? I'm just going to keep going. How high does it go?
1.
Minimum. -1. What are my horizontal asymptote, which is the center of my wave intercepts? They are located at 0, pi, and 2 pi. What is my max value in cosine? Also 1. -1. But now I only have 2 intercepts for cosine. They are at pi over 2 and 3 pi over 2. Questions on that?
Yep.
All right, so what I want to do is, I believe over here you can still see this. I'm going to draw a quick sketch. 1, 2, 3, 1, 1. This is sine. Then down here I'll do the green and cosine, just so we can talk about it a little bit differently. Boom, 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 boom. This is going to cross here, here, up 1, down 1, up 1. There it is. Okay? Please do not make these a V. Please do not make it like a U. It's not. It's a curve. It comes down and it comes back up again. Okay? Moving forward. These are so much fun. First thing we can do is, just like our parabola, we can reflect the graphs. So notice I've drawn already the original graph we just went over. If I want to draw negative sine, I have the same intercepts, 1, 2, and 3. However, rather than going up at pi over 2, I'm going to go down. And rather than going down, I'm going to go up. So it rotates around like a cyclone. Coming down, up, and around. Let's not discuss anything else that looks like these graphs. Infinity symbol.
No, I see you.
Okay. So the U open down, this is now a rotation around the center of the wave. Negative cosine, a little trickier to see. Same 2 key points here and here. Rather than going up 1, I'm going to go down 1, up 1, down 1, and then I'm going to create this wave.
It's up.
Okay, negative cosine. Questions on that? Before you leave here, I will give you a pack of plain paper. I would suggest doing your graphs on plain paper. Don't use line paper. I think it's easier. It'll make more sense, especially when we start changing the x and y axis values. You'll see what I mean. All right, so first thing is a reflection. Next thing. Okay? When we graph, when you are asked to graph, you are going to need to label both the x and y axis. Okay? If I talk about radian values, which is what I've introduced to you because it's the newest part, the hardest part to kind of get involved in, our radian values are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. They're all of the 90-degree angles. Most likely we're going to go up one and down one. Sometimes we go further than that. But when you draw these, because you're not going to get outline drawings, you're going to have to actually label your x and y axis in all of the problems. When we do degrees, it's 0, 90, 180, 270, and 360. We're going to go up 1, down -1, and from there. Okay? You will see some of these when it says pi over 2, it's going to say 0.5 pi. It's just because of the generator we used online from back in the day. So you should be labeling them using the radian values. Don't use the decimals. All right. Next topic. What happens when we have an amplitude change? Amplitude is the height of the curve. Now, there's something really, really cool about sine waves, cosine waves, waves in the ocean, any of that. Whenever you see a wave that comes up, it will always have a comparable, exact mirror image that goes down. The next one might be smaller, but there will always be a mirror image of those that is exactly the same. That's why you see it come up, it crashes, it comes down, goes all the way around, and then it comes back up again. It's one of the really cool features of waves, in my opinion, just the fact that it always is equal and opposite. So when we talk about amplitude, we're going to talk about the height. The height of the curve is always from the center line. It's not the total from bottom to top, from trough to wave height. It's always going to be measured from the center. So it's a little misleading when we say wave height, because it also could be how big the hole is. It's equal and opposite, the same value, right? We find this value in the notation with the A in front. So right here, whatever is multiplied out front is going to tell us the size of the wave, how much we count. So that's something else I'd like you to know. The amplitude is a count. Okay? Do not look at that number and think it corresponds to the axis. It doesn't. It's a count from the center of the wave. So if you look at your first example, we have y is equal to 2 sine x. The 2 is out front. We're going to graph this between 0 and 2 pi. So if this were you, if I were you, and this was a homework problem, I'd say, okay, 0 to 2 pi. I got that. I'm going to come over here. I'm going to label 1, 2, 3, split it up. 0, pi over 2. 3 pi over 2 is over here. This is pi, and this is 2 pi. Right? Go right around the unit circle. How many points of sine fall on the center wave? Center of the wave. How many points does sine have? 3. So I should see 3 points. I'm going to do this in green even though it's not the same. 1, 2, 3. Now I'm going to take into account wave height. My amplitude is 2. Normally I would go up 1, correct? From here I would count up 1. But now because my amplitude is 2, I'm going to go up 1, 2. And over here from the center line I'm going to go down 2 to -2. Up, down, and around. Done. So, yes, this is 2, this is 2, it looks like 4, but the wave height is measured from the center of the wave. Here's your wave center. Notice I've graphed between 0 and 2 pi. Any questions? Seem easy? Yes? All right. We could ask you questions about the max and min. The highest value now is 2, the lowest value is -2. Don't automatically put these numbers in based on this, because we're going to eventually be moving the graph up and down. So look at the picture you generated and actually label and count on your y-axis to find your max and your min. Next problem. Let's just go hard right from the beginning. Okay. let's talk about y is equal to negative 4 cosine of x. Thought process. Wait a second. That's not 0 to 2 pi, 0 to 360. It's outside of that, correct? Okay. My suggestion to you is this. Graph between 0 and 2 pi and then repeat the pattern. So focus only on 0 to 2 pi. So here's what I mean by that. Take this. I'm going to go all the way here. Instead of 2 pi, I'm going to do 360 degrees, and I'm going to put my values in. 0, 90, 180, and 270. I understand that the directions are going to have me do more than that, but for right now, let's do 0 to 360 and follow the rules. Cosine has how many key points on the center line?
2.
2. So we're going to plot those 2 key points. I'm going to plot it here, and I'm going to plot it here on the center line. Normally, I would count up 1. However, what I have out front tells me I should count how many and which direction. Down 4 from the center line. So from here, I'm going to count down 1, 2, 3, 4, and put a dot. From 180, I'm going to count up 1, 2, 3, 4 from the center line. From 360, same thing, I'm going to go down. So when I draw this, that is the graph of negative 4 cosine x between 0 and 360. I'm now going to expand the pattern. So what comes after 360 if I add 90 to it? Mental math. 450. Not quite there yet. Add another 90. 540. One more. 630. Right? So now I'm going to take my graph and say, okay, I'm going to start just like here. I'm going to start here. So it's going to cross at, what, 450 and 630. This is going to be up. This is going to be down, and I'm going to connect it. Every quarter should match to the original. So notice 0 to 90, what's in here, matches to 360 to 450. 90 to 180 matches to 450 to 540. And then I only have one more. That covers my information to the right. Now I need to go to the left. Negative 90, negative 180. Repeat the pattern, back up to here. This one's going to come up to the top. Too fast, or are we okay? They're writing myself. So in other words, if 450 was in radians, because I went off of this graph, the home graph, it always crosses at those two places, 90 and 270. So I'm taking that root equation graph. Remember, like we would talk about that key vertex and moving it? I'm moving 5 key points now. Okay, it just so happens that these two always fall on the second and fourth of the 5 places. Yes? Does that make sense? Okay. Questions on that? Not too bad so far, right? All right, here we go. All right, so we did this, we did all that already. Okay, so now let's talk about shifting up and down. Just like the warm-up problem, we can take a graph and we can move it up and down by the center line. So the plus or minus is moving the horizontal asymptote, in other words, what you've seen before. Okay, it causes the vertical shift. The rules are the same as what you've seen before. Okay. So if we take a look at the next example, cosine of x minus 2. The minus 2 is at the end. It tells us we're going to take the cosine graph and we're going to drop it down. Notice the interval I asked you to graph on is not 0 to 2 pi. I still want you to graph for now from 0 to 2 pi, and then we'll expand it into the negative pi. I want you to reinforce what you're seeing here for the home graphs, and then we can use those to create the parts that we need. So for example, for cosine, I'm going to go 0, here's 2 pi, here's pi, 0, pi over 2, and 3 pi over 2. All right? Now, this is the reason why I want you to do this on plain paper. If I ask you to take the center line and drop it down 2, if you were dealing with graph paper, you would have your axis and you would go down 2, correct? What I want you to do is just label this as negative 2. Create your axis at the negative 2 value. That's your center line. That's the one you're going to work off of. Now the process is exactly the same as what we did before. Do I have any amplitude change out front? No. I don't have any negatives, I don't have anything, so I can just graph this, crossing at pi over 2, crossing at 3 at pi over 2, up 1, down 1, up 1, and connecting them. The only trick to this is the fact that my higher value isn't 1. What's the higher value now? Negative 1. And what's the lower value? Negative 3. So just be aware of what your new y-axis values are. And now, like the last problem, let's expand our axis. So this is pi over 2. So now I'm going to go to negative pi over 2, and then what? Negative pi. Repeat the pattern to here. This comes down to here. So the part of the graph that I really, really need is this part of the graph. This is my real solution that I'm kind of squiggling. But I want you to reinforce what the 0 to 2 pi looks like. That's what you're going to deal with most of the time. Questions on that? Now, the other tricky part to this is the fact that it looks like it's at the x-axis. Just remember, we shifted it down. It's actually below the x-axis. Yes?
We did have to label the y-axis.
But I have to what?
We did to label the y-axis.
Well, I could ask you questions about max and min. The maximum would be negative 1, the minimum would be negative 3. So it's probably a good idea, especially since I'm letting you kind of shortcut, not having to draw 0 and then count randomly. All right, so we did all that. We're good with that. All right, example 4. Let's put it all together. You try it. And I was even nice and gave you 0 to 360. Second time today I'm being nice. First time was the room changed. Now I'm just giving you an easy problem. So what's your new y value? What's your new y value? That's the center line, but what's the new maximum? Well, it should go up to 4, but the other thing is what is the negative in front of it? The amplitude. You don't know? Okay. Watch that negative in front of the sign. The S-I-N sign. That negative out front does change the graph. It affects the amplitude. You can rework your axis values, your y values, that's fine. Follow the same procedure we just did. You don't have to shift it down. That works. You could have also just followed this axis. Which is what I would highly recommend doing for the homeworks. All right, following the same pattern, just took a quick lap to see where you were at. First thing I would do personally, especially if this was a homework problem, is I would label this as +1. I understand it's not, but just visually, I think it's easier if you always use that center line axis as the middle of your graph. So yes, it's going to affect your y-axis values. That's fine. Okay, so I'm at +1. We're talking about sign. That's always going to be 3 key points. That's not affected by any changes. Sign always has 3 key points on the center line. What does change is the -3 amplitude. Instead of going 90 up 1, counting, I'm now going to go down 1, 2, 3. At 270, I'm going to go up 1, 2, 3, put a dot, and then I can connect these. However, notice if this is +1, 2, 3, this is going to go all the way up to 4. +1, 1, 2, 3, this is going to go down to -2. So your max would be 4, your minimum would be -2, and you would have your graph. Yes? You're counting from the center line. So -3 says go 1, 2, 3 down, so from 1 that corresponds to -2. Always use amplitude as a count. Good? All right, turn the page. All right. First statement I'm going to make is that if I ask you the root equation for sine and cosine, what is the period of that? The period is always going to be 2 pi. Okay, so the period is going to be 2 pi in length. So what that means is it's how long along the x-axis do you need in order to draw one complete part of the graph. So those two require 2 pi in length, or 360 if we're talking about degrees. Well, if I think about this going to 2 pi, I technically could take that graph and I could shrink it back so that I would have 1 revolution of it, second revolution of it between 0 and 2 pi. That's called a period change. That's what we have right here. It's denoted by multiplying something by x. So it's not multiplication in front of the trig function. It's actually multiplication of the variable involved. To calculate the new period, you're always going to take 0 to 2 pi and divide it by whatever the coefficient is. Write it down, and it's easier if I just do examples and show you what it looks like. This is a lot of notation, and especially since you're new to these equations, it's going to seem a little overwhelming until we actually work with the data. Work with the examples. Okay, so this is my radian value. Take 2 pi and divide it by b. This is going to be my degree value. That's why there's 2 separate statements. From this point forward, when you are asked to graph, I only want you to graph one complete period. So let me show you what that means. All right, so let's talk about the sine of 2x. All right, the period, if I say what is the period, you're going to write down 0. Since I'm dealing with x, I'm going to assume that it's radians. Okay, x means radians. I'm going to take 2 pi, and I'm going to divide it by this 2 right here. So my new period is going to be 0 to pi. What that means is that when I set up my 1, 2, 3, 4, 5 values, my key x values are no longer going to be 0 to 2 pi. They're going to start at 0, and they're going to go to just pi. Another reason why I like not using graph paper, because now the process looks the same even though you are labeling the axis different. What's in the middle between 0 and pi? Think of the unit circle. Pi over 2. What's in the middle between 0 and pi over 2?
Square root 2.
Pi over 4 and 3 pi over 4. Okay? All I did is shrink the x and y value, the x values rather. I didn't do an amplitude change. I didn't move the graph up or down. Nothing else changed. So I can actually have this go up to 1, this go down to -1. Okay? I didn't change this, so y equals 0 is going to still be my center line. My amplitude is still 1. It's understood because it's multiplying times sine, so it's a 1. How many key points are on the center line for sine? 3. 1, 2, 3. At pi over 4, I want to go up 1, count, down 1, and draw my graph. All right, take a second, reflect on that, ask any questions. What did I do that you didn't understand? Can I explain? How did I? Blah, blah, blah. Good ways to ask. Yes, sir.
Why wouldn't those, the power of 4 and the 3 power of 4, why wouldn't that be like 32? I mean, oh wait. Alright,
Because the x input value is the radians, the output is the actual sine. That's why what you did yesterday was really important. The what do you call that? Like the actual concrete numbers of it. Because now we're going to go to more the abstract curves. Now, here's what I want to show you. This red curve that I just drew right here, if I drew it in the context of regular sine, it would look like this. It would come up, it would come down, and around. This graph right here is y is equal to sine of 2x. Does that make sense how I have 2 of them in the same pattern that I used to have 1? But you only draw 1 period, which means you only need 1 completion of the wave, which is illustrated between 0 and pi. That's what you're looking to do. 1 period doesn't mean always just show me between 0 and 2 pi. Good? All right, let's try the next one. Here we go. All right. Now we're going to go all out. All out, all out. First of all, you can let out a big cheer because we're not dealing in radians. What are we dealing in?
3.
Theta is degrees. So y'all love degrees, which is fantastic. Let's follow the period rule. The period rule says we're going to start at 0. Sine normally has a period of 2 pi. What am I going to divide 2 pi, not 2 pi, 360 by?
1/2.
1/2. Oh, fractions are our friends. 360 divided by 1/2 is 720. What? 0 to 720. So I took my graph now, instead of shrinking it back, I'm actually going to expand it out to make it bigger. So I'm going to start at 0, 2, 3, and I'm going to go to 720. All right, so now I need to ask the question, is anybody confused about that? We all okay with switching to 720 and moving forward? Speak now, forever hold your peace.
Alright.
Okay, what's in the middle? 180. What's in the middle here? 540. All right, sweet. Wait a second, the graph shifted how? Up 1, right? Didn't it go up 1? So I can label this as positive 1. This is positive 1, this center line that I have. What's my amplitude? This is y equals 1. My amplitude is positive 3. So that means it's going to look like the typical sine wave up and down. However, I'm now going to change the amplitude of that. How many key points fall on the center axis?
3.
3. 1, 2, 3. I will take a TV timeout. Questions on anything I've done to there? Do you need me to repeat it, or why did I? Anything. 180. Do I count up? Do I count down? From 180. Count up. How many? 1, 2, 3. Puts me at a max of 4, correct? And then over here, 1, 2, 3 puts me at a min of -2. I'm going up, I'm going down, I'm coming around. What do you think? You didn't think we were going to stop at the unit circle, did you? Oh no. Oh no, oh no. All right, now, please put a star by example 3. Example 3. Those of you who hate radians, please take exceptional notes here. The notes I'm about to give you are going to be the same ones that I reinforce on the new lesson tomorrow. So it's something that I don't have to show you today, but I want to create the pattern that's the same so that all the problems are done in the same fashion. The reason I say that is I'm no longer dealing in degrees. What am I dealing with in the next example?
Radians.
Radians. And when I look at radians, I have fractions. And I have more fractions because look at your period change. Okay? So, again, put a star by this. Take very good notes. I'm going to go slowly. We have a good 10 minutes or so, plus a few, 13 minutes to just finish this one problem. If at any time you're writing it down, you're like, I have no idea what she's doing, please ask, because I guarantee there's someone else. Here we go. Step 1, period. I write down a 0. Then what do I write down? What's my work before I do the calculation? 2 pi divided by what?
2 over 3.
2 over 3. Okay, whether it's in your head or otherwise, can you tell me what the new period is?
0 to 3.
0 to 6 over 2 reduces to 3 pi. Okay, first stop about questions mathematically. Stop the bus, open the door. Any questions? Nobody got off the bus? We're good?
I'm good.
Close the door. Let's keep going. 0 to 3 pi. Next step, label your x-axis. 0, 3 pi. Okay, so this is the one thing I'm showing you that is new. Disclaimer. Disclaimer. What are my normal 5 values? I normally have 0, pi over 2, 3 pi, pi, I go in order, 3 pi over 2, and 2 pi, correct? Yes?
Mm-hmm.
Okay, if I set each of those equal to 2/3 x, for those of you that don't like radians, okay, so I'm taking this right here, and I'm always setting that equal to the 5 key points that I normally have from my graph. I'm going to erase this extra one for now, just so it's not confusing. Okay? I can now solve for the 5 key points that fall along the x-axis. So 0 is going to be 0 when I solve this. That's not a big deal. What do I get when I multiply by 3 over 2? I multiply this by 3 over 2. What do I get? What's this simplified? Hello? What do you get? 3 pi over 4. Okay, next stop in the bus, right there. Stop, open the door. Questions on that? Okay, close the door, moving on. What do I get when I take 2 pi over 3 times 3 over 2? Am I getting rid of this? 3 pi over 2, there's my middle value. Next one, times 3 over 2, got rid of this. 9 pi over 4. And just to verify, if I multiply this by 3 over 2, don't I get 3 pi? That is the easiest way to always come up with the 5 correct key values. You take the 2x minus 3, you set it equal to the 5 key regular points, and you solve to come up with your 5 new values. Where's my center wave? What's the y value of the center wave or the horizontal asymptote value? -1. So this is at -1. We can label that. Y equals -1. My amplitude is -2, correct? Now I can start to graph. How many key points does cosine have on the center wave? 2. 1, 2. That part doesn't change. Normally for cosine, I would count up 1. What am I going to count in which direction and how many? Down 2. So from here, I'm going to go 1, 2 down and put a dot. From the center, up 2. From this end down here, down 2 again, which puts me at -1 and up to +1. Not -1, -3. All right, before I connect the curve and confuse, does anyone have a question about where these 3 dots come from? Anyone have a question about dot number 1? Dot number 2? Dot number 3? If you're sleeping, stay sleeping. Okay, so then from there we just connect to draw the curves. Ta-da! There's your cosine. Alright?
Not too bad.
You have 14 problems. The first 7 are actually super easy, I think, compared to the ones that we just did. I'll get you some clean paper right now, and we can actually stay